Hi everyone. In this video we are going to discuss multi-agent orchestration, and we are going to start our discussion with Google's A2A protocol or agent-to-agent protocol, and then we explore the alternative ways of orchestration. Then we will consider pros and cons of A2A protocol, and then we explore alternative ways of doing similar things. So let me briefly start with description of A2A protocol. I will have a separate video on my channel dedicated to A2A protocol, but for now I'll just give a very brief overview of the protocol. So A2A protocol allows agents to exchange messages with each other, and Orchestrator agent, once it has a task, it can decide a right agent to select from the list of the agent it is connected to. Let's assume we have Orchestrator agent, and it is connected to hotel reservation agent and airplane ticket booking agent. In order to be able to use hotel agent and airplane ticket agent using A2A protocol, we'll have to wrap those agents into A2A executor, and we will run our agents behind a particular endpoint. And these endpoints are HTTP endpoints. So basically what A2A protocol is doing, it is taking the agent and wraps it with A2A executor and deploys this agent as a web server. So now we can talk to this agent using HTTP requests. So the Orchestrator agent can send messages to the A2A compatible agents, and in general we can send messages and the tasks or task status. So a quick recap. In order to use agents via A2A protocol, we will have to deploy agents in a special way, that the agents are wrapped using A2A executor and deployed as a HTTP servers, enabling A2A protocol messages. So the agent which is deployed this way is a server agent, and the Orchestrator agent which is using the server agent is a client agent. So the Orchestrator agent will need to have a special tool which is sending A2A messages. What is the benefit of this approach? The benefit is that in A2A protocol, there is an instance called agent card, which contains all the information about the agent. So agent card contains the name of the agent. In this case, this is a hotel reservation agent. Description: the agent is experienced hotel room reservation manager. It contains the URL of the agent, and it contains the default mode of input, default mode of output, skills, version, and capabilities. And there is a separate object for the skills as well. So the skill, a separate ability of the agent. So it contains ID. It refers to the agent name. It provides the description of what agent can do, what skills allows agent to do. Then it also has associated tags. In this case, room reservation, check reservation, cancel reservation, and so on. And also example queries, something like need to reserve a room, need to check reservation status, need to cancel reservation. And basically using the agent card, it is possible for Orchestrator agent to select the agent which is at this moment is the most appropriate agent to perform the task. However, we have to write a special A2A executor. We have to deploy that agent as a web server, and also A2A agent is now accessible only through A2A protocol, which is another limitation. So the list of pros contains ability of the Orchestrator agent to find the corresponding agent using the agent card. And I think this is the main advantage of the A2A protocol. On the other hand, we will have to create the A2A executors to wrap the particular agent. We will have to deploy the agent as web servers, and now these agents are becoming only A2A compatible. We cannot connect those agents using other protocols or in other different ways. So is there any way that we can dynamically select the agent depending on description of their skills or functions? So the answer is yes, but before I give explicit answer in details, let me compare A2A protocol and Model Context Protocol, or MCP for short. So the agent-to-agent protocol, or A2A, is used to enable communication between agents. So it is an agent-level protocol. So the orchestrator agent can talk directly to the server agent or the service agents which we need to use. On the other hand, MCP protocol has been designed to outsource or take the agent tools outside from the agent, and the idea is to deploy these tools as servers. So in this case we have MCP server, which is reachable using the MCP and HTTP requests, and at the backend MCP server tools are connected to associated APIs. So for example, if there is a weather API tool or weather tool, we can connect to weather API. If there is a Forex API tool, we can connect to Forex API at the backend, and so on. The beauty of the MCP protocol is inherited from the beauty of the agent structure, because agents select tools depending on the definition of the tools. So more specifically, I show this in the code, but the tool contains a definition when this tool should be used, and usually this definition is provided as a docstring in the body of the tool. Also, the name of the tool and the parameters are also taken into consideration, but the most important part is the description as a docstring. So therefore, once agent, let's say agent 1, is talking to MCP server, the MCP server will select the best fitting tool which corresponds to the agent request based on the description of the tools. So this is very similar to the agent cards. So the tools, they have their own description, and we can select the tools on fly using their description and comparing their description to the actual current request. On the other hand, A2A protocol also uses agent cards to enable on-fly selection and activation of agent which is most suitable for the current orchestrator agent request. So if we can use the MCP protocol to orchestrate the agent, and the answer is yes, we can do that. So here, instead of just providing the API, we can deploy the associated agent behind the API endpoint. So for example, instead of just using some simple function to look up the weather from the database according to the geographic location, we can use the agent, which will do the more complex things rather than just function calls. The same is for the Forex API. We can deploy a Forex agent behind the API. So regarding the MCP protocol, how to deploy the MCP servers, how to define the tools, even how to deploy MCP proxy, and how to define the MCP tools and associated APIs, I have a dedicated video which provides in-depth step-by-step explanation. And in that video, I am basically using three types of MCP hosts. First, it's MCP client, AWS Trans Agent, and ADK agent. So in this video, we will follow the similar setup. We will use MCP client, AWS Trans Agent, and ADK agent as methods to communicate with MCP server. We will deploy multi-agent MCP server, which contains two tools tool number 1, call poetry agent, and tool number 2, call reg agent. Each tool is associated with a dedicated API. So tool 1 calls poetry agent API endpoint, and tool 2 calls reg agent API endpoint. In order to deploy API endpoints or HTTP server, we use fastAPI. And within fastAPI, we will explicitly define the endpoints for the poetry and for reg agent. And behind the scenes, these agents, the poetry agent and reg agent, are implemented in the form of semantic kernel poetry agent and semantic kernel Azure AI search agent. I have a separate video about semantic kernel poetry agent and how to set up a simple semantic kernel agents using Azure deployed ChatGPT models. On the other hand, the semantic kernel Azure AI search agent, I will create a separate in-depth video, but in this video we will simply use the code and I will briefly explain how semantic kernel Azure AI search agent, or reg agent in short, operates. So this is a brief introduction about what we are going to do in this video. And next, we will define the agents, the poetry agent and Azure AI search agent. We will deploy the API endpoints for poetry agent and for reg agent. We will create and deploy multi-agent MCP server with 2 tools, and we will create MCP client, AWS Trends agent, and ADK agent. So next, let us check the code. Let's begin our code walkthrough with analyzing the agents which are sitting behind the API endpoints. We have 2 agents, poetry agent and reg agent. To implement these 2 agents, I have selected to use Semantic Kernel SDK by Microsoft. This SDK is fully compatible with Azure Cloud and Azure AI Foundry. I have a separate video with a walkthrough how to set up basic semantic kernel agents and how to set up necessary credentials at the side of Azure AI Foundry. So here I will provide a quick run through the code. So first we are defining our chat completion agent. This is imported from semantic kernel agents. Next we need Azure chat completion. This is a service which we will use to connect to Azure AI LLM model. In this particular case, this will be Open AI Chat GPT model, which is deployed in Azure AI Foundry. So Azure Chat Completion module is imported from semantic kernel connectors AI OpenAI. I will skip explanation about normalize Azure endpoint function. It is described in my previous video. And here we are getting to the center function. So this is our poetry agent, and it takes prompt as an input. So first thing that we do, we load the environmental variables. So we get endpoint, deployment name, API key, and API version. How to get these parameters and where you can find necessary credentials, please refer to my previous video. I am showing explicitly where you can get these values and how you can find them in Azure AI Foundry. Next, we define our agent as a chat completion agent, and as a service, which is basically our LLM service, we define Azure chat completion. Here we need deployment name. In this case, this is GPT-5 Nano, API key, endpoint, and API version. We name our agent SK Assistant, and instruction is you are a helpful assistant. After that, we invoke the agent by calling getResponse method of the agent with message which equals to the prompt, and we get a response. We print response and return response content. To run this code, we are taking one parameter from the command prompt. If this parameter is not provided, we will use a default prompt, write a haiku about semantic kernel. And then finally, we run our main function which contains the agent. Let me activate my Python virtual environment. And let me run this code to show that this agent actually works. And let me run the code to show that agent actually works. Okay, semantic kernel bridges data, code, and dreams, plans emerge in code. So this is the haiku provided by the agent. Now let us do a quick run through the second agent, which I called reg agent. And more specifically, this agent implements retrieval augmented generation using Azure AI Search. I will make a separate video how to set up all the necessary infrastructure on the side of Azure and Azure AI Foundry, and where to find the data and how to create the index and the vector database in order to enable the reg service itself. For now, I will run through the code to give you the idea how this agent works. So first of all, we will import Azure AI Search tool, which is the tool which will help us to connect to the... Then we will import connection type and Azure CLI credentials. As usual, we use load.env from .env. This is to load our environment variables from .env file. And then we will use Azure AI Agent and Azure AI Agent settings. So these modules are imported from semantic kernel agents. As you can see, this time we are using different classes to create the agent, in contrast to this simple poetry agent. Here we use chat completion agent and Azure chat completion service. Here we define the default index name. This is our database containing information about the hotels. And next, we need to create Azure AI agent settings. So this is done inside the get agent settings function. So here we are getting the model deployment name as in the previous example. We are also getting the endpoint, and we are creating all the necessary objects, all the necessary dictionaries to be stuffed inside the Azure AI agent settings. So the function get agent settings, creating Azure AI agent settings object for us. Then we are basically checking if the connection to the Azure AI search service is successful. This is done using isAI search connection function. Then we use the function resolve search connection ID. And then finally we get to the reg agent. So the reg agent takes prompt as an input. First, we are getting AI agent settings from get agent settings function. We get the index name, which is our default index name. And next, we are doing two things. So first, we are enabling Azure CLI credentials, and we are creating the client using this credential. So here we call Azure AI agent and create a client. So this client is necessary to establish connection. So for creating this client, we need credentials, we need endpoint, and we need API version of that endpoint. Again, I will show you all these details in the separate video, and it will be a big walkthrough of how to set up everything on the side of Azure and how to configure your own environment as well. So next we are getting the client object, and using this client object and AI agent settings, we are now creating the AI search connection ID. And then we finally use this AI search connection ID as index connection ID in Azure AI search tool, and we also use index name as index name. Next, we need to get our agent definition. So this is a specification of our AI agent using the model, instructions, tools, tool resources, and headers. So the model is the name of deployment model. In our case, this is GPT-5 Nano. Instructions are answer questions about hotels using your index, so the index we provide. We provide AI search definition as a tool, and in addition, we provide AI search resources as tool resources. Then finally, we create the agent itself. This is Azure AI agent, having a client as a client, which we have defined here, and definition as agent definition, which we have just discussed. So finally, we are running the agent with a prompt. So we are invoking the agent using getResponse method, and we provide the message as a prompt. So this is our original input parameter into the RAG agent. So this is the prompt which will finally go inside the getResponse method to invoke our agent. And then finally we get a response and we return the response as a string. Okay, so to run this code, we can either provide our prompt directly, or if there is no prompt provided, the default prompt is which hotels are available with full-sized kitchen in Nashville, Tennessee. And then finally we run our agent. Let me clear the console and test our RAG agent. Okay, so this is our original prompt. And here we have a list of 5 hotels with hotel names and a description how this hotel fulfill our requirement. Alright, so both agents are working. And now it is time to create the HTTP server and deploy the API endpoints. So I'm going to deploy HTTP server and our API endpoints using fastAPI application. So I import fastAPI from fastAPI. So in order to deploy our HTTP server and the endpoints, we are using fastAPI library, and we import fastAPI module from the library. Also, we need async IO to do the asynchronous calls and the login. Here, I import all the functions and all the code from the SK Azure Poetry agent, which is our poetry agent, and SK Azure AI Search agent, which is our RAG agent. And now we can define fastAPI application. So the first endpoint is get method endpoint residing at Azure Poetry agent URL and taking prompt as a and using prompt as get method parameter. So our API endpoint uses get method in order to get the data. The actual function sitting behind this API is invoke Azure Poetry agent, which is taking the prompt parameter from the GET request. So this function invokes the Azure AI Poetry agent behind the API. So we print the prompt and we run the Poetry agent function from SK Azure Poetry agent. So as we have seen, this Poetry agent function will collect all necessary credentials for the agent, create the agent itself, and invoke the agent with the prompt. And then here we will get the Poetry agent response. And this will be the response of the endpoint. Next, in a similar way, we set up API endpoint for reg agent. So this is Azure reg agent with the parameter prompt, and we also use the give method to pass the information. Our function is invoke Azure reg agent, and here we invoke function reg agent from SK Azure AI search agent. Once we get the agent response, we are returning the agent response as the response of the API call. Okay, so now let me set up the endpoint. And now let me create the fastAPI application. To do so, we need unicorn command. Then we provide the name, SK Azure Agents API. And we provide the application variable or app. And we deploy web server at port 8000. Okay, now then our API endpoints are successfully deployed. Let me try running it using the prompt. So first we are going to invoke the Poetry agent with the same prompt which I used for the agent test. Write haiku about semantic kernel. And here we get the response. Basically, this is response from the GPT model. It's GPT-5 Nano. And here is the response. Semantic kernel guides the agents with data, answers arise in code. Okay, so this Poetry agent API endpoint works. Now let me try reg agent API endpoint. And here I also use the same prompt which was employed for the reg agent test. Which hotels are available with full-sized kitchen in Nashville, Tennessee? And here the responses are text as we converted it into the string. So this is not a JSON file. All right, now that we made sure that our API endpoints work, we are going to create the MCP server, which is connecting to these API endpoints. I have a very big video about how to set up the API endpoints, MCP server, and even MCP proxy. So please refer to this video for further details. So next we are going to create our MCP server. So we use fastMCP library and import fastMCP module from that library. We will also need requests and JSON. So first we create our MCP application, and this is our multi-agent MCP server. Next, we define our tools. So in order to define the tools, we are using mcp.toolDecorator. This is similar to the way we define the API endpoints. Here we use application.get decorators to create the endpoints. In case of MCP servers, we have created mcp.tools to create the MCP server tools. And the first tool is invoke Azure Poetry agent, which is taking prompt as an input. And this tool is to invoke helpful assistant agent to write poetry, including sonnets, haiku, etc. So this part, line 9 to 11, this is exactly the doc string which is explaining what the tool is doing, and this is the analog of description field, which is taking prompt as an input. And this tool is to invoke Azure Poetry agent, which is to write poetry, including sonnets, haiku, etc. So this part, line 9 to 11, this is exactly the doc string which is explaining what the tool is doing, and this is the analog of description field, in the A2A protocol agent card. So next we define a URL. In this case, this is Azure Poetry Agent prompt. So basically this is a complete API endpoint. And using the request object, we are creating a HTTP request using GET method to this URL, and we are getting response. So if response is successful, we are returning response as a JSON, and if not, we are saying that we don't have any data. In very similar way, we are creating the second tool to invoke Azure Reg Agent, and this tool is to invoke Azure Reg Agent to search information about the hotels in the city of your choice. In a similar way, we define API URL, which is URL for the Azure Reg Agent endpoint. We create HTTP request using GET method to this URL, and we are getting the response in the JSON format, and this is response of the tool. If we don't get any response from the API, we are saying that there is no data. So basically we are creating the dictionary saying data is none. So now let me deploy MCP server. First, I will activate my Python virtual environment. Okay. And now I'm going to deploy MCP multi-agent server. Alright, our server has been deployed successfully, and it is deployed at the port 8001. So this is where we are providing the host and port parameters for our MCP server. And now we need to test this MCP server. I will show you 3 methods how to test this MCP server. First, we are going to use simple MCP client. So we import client from fastMCP library, and because our MCP server is using streamable HTTP transport, we will import the same module from fastMCP client transport. And we also use async IO as we do the asynchronous calls. So our MCP URL is the URL of our HTTP server, and we need to provide MCP endpoint. So in the main function, we first create a transport, which is streamable HTTP transport with URL equal MCP URL. Then we create a client with the transport as a parameter, and now we have our MCP client set up. Next, we are going to use this client. So first, we will request a list of tools from the MCP server. This is done by calling list tools method of the client object. So we will get the tools dictionary, where we get the tool name and description of the tool from all the tools returned by the MCP server. And here we print out tools dictionary. Next, we will have a short list of only having the names of the tools, and we print out these tools separately just to show what tools are available on the MCP server. Next, we go into invoke these tools one by one. So first of all, we will create a prompt. In this case, this is again, write a haiku about semantic kernel. And next we use call tool method of the client object. Here we provide the tool name, and we provide the parameter prompt, which is input parameter for our tool as a prompt. And here we get the result, basically response from the API, which is delivered through the tool. So this response will be in the form of a JSON, and we can see the structured content, or we can directly get the text response from that structured content. Next, we are going to invoke the Azure Reg Agent tool. So we use the same prompt, which hotels are available with full-size kitchen in Nashville, Tennessee. We use call tool method of the client object again, now with the different tool name, which is invoke Azure Reg Agent in this case, and the prompt parameter is our prompt. However, there is no JSON in this case, so we are getting from this result directly the content and the text. Alright, so this concludes the client definition. Let us run the MCP client. Now let us run our MCP client. Okay, so this is our dictionary of tools with the tool name and associated description, which is exactly the docstring we provided for the corresponding tool, and we have 2 tools and 2 docstring descriptions. Here's the complete list of the tools. We only have 2 tools as we defined in our MCP server, and now we are expecting for the response from the first tool. Alright, that took a while, and here you can see the raw result, which is basically output from the tool, and here you can see the original response from the model. And finally, this is the structured content, which is a subset of this entire object. And here is the HYCLO, semantic kernel, guides, memory, tools, and prompts, softly sparks, replies. And next, this is our reg agent results. And here is the answer in the form of the raw text. As I mentioned, since we did not pass the proper JSON object, our response from the reg agent is a text, which sits within the text field of the text content of the tool call result. That's why there are 2 different ways of extracting the final text response for the poetry agent and for the reg agent. Alright, we have successfully tested MCP client. Now let us have a look how we can use 2 more ways to connect to the MCP server. In this case, I'm going to use AWS Strengths Agent and Google ADK Agent. So let me start with AWS Strength Agent. On my channel, I have a series of videos about the AWS agents. Here I show how to set up the basic agents, how to select different LLMs, how to do the various things with the agent like hooks and callbacks to intercept agent runtime. So please refer to these videos to get the basics of AWS Strengths agents. So here I will provide a quick run through the code. So first of all, I am importing streamable HTTP client in order to connect to the MCP server from MCP client streamable HTTP. Then I import agent from Strengths, and then I import MCP client from Strengths, Tools, MCP. Then finally, I use a Bedrock model as a LLM for the agent. So first, I'm going to set up streamable HTTP MCP client. So this is a MCP client with streamable HTTP client object and a URL localhost 8001/MCP. So this is the same URL we used here in the MCP client code. So next, with the streamable HTTP MCP client, we are either getting the parameter prompt, or we are using the basic prompt, what is the capital of the United States. So here I define the Bedrock model. In our case, this is Nova Pro version 1 with temperature 0.3 and streaming true. And as tools, this is our streamable HTTP MCP client. I can list the tool from the server. So this creates a list of available tools from the MCP server for the agent. So finally, I create the agent with tools as tools with model as a bedrock model, and the system prompt, you are helpful assistant. So this is a general agent which is going MCP server, so we do not provide any specificity of a particular task. Let me remove the print around the agent prompt, and let me run the code with write a haiku about semantic kernel. So here we can see agent reasoning, create a haiku about semantic kernel. I will use invoke Azure Poetry tool. Here the agent calls the tool, and the agent provides us with a haiku about semantic kernel. Semantic kernel guiding minds with nimble tools, streams of context bloom. Okay, now let me try to use the reg agent. So I will use a different prompt, which we use basically to invoke the reg agent. Which hotels are available with the full-size kitchen in Nashville, Tennessee. To find hotel in Nashville, Tennessee with a full-size kitchen, I should use invoke Azure reg agent tool. So the agent reasons and understands that this tool should be used. Now the agent invokes Azure reg agent tool, and here is exactly the response which we were expected to see and what we have seen previously. Now we can see that AWS Trends agent is able to connect to the MCP server and invoke the tools which are invoking endpoints backed up by the agents. And we have shown that we were able to use both tools of the MCP server. Now, finally, I'm going to use ADK agent by Google. So here is a quick code. You will have to create the separate directory. I have a walkthrough showing how to set up ADK agents in that big video, which I mentioned previously. So please refer to the detailed structure of the folder. Here I will just show you a brief code how the agent can be implemented and bind it to the MCP server. Okay, so first we import agent from Google ADK agent. Then we need MCP toolset, which will be our connector to MCP server, which comes from Google ADK tools MCP toolset. And then we also need streamable HTTP connection parameters. So this is to configure our connections to using the streamable HTTP transport. This comes from Google ADK tools MCP tool MCP session manager. And then we need to load.env from .env. Here we will require two things. So first of all, we need Gemini model name, and in this case it will be Gemini 2.5 Flash. And also we will need API key to invoke the model. So this information we will get from the .env file. So next we create agent MCP toolset. So the toolset requires connection parameters as streamable HTTP connection parameters. And this object takes agent MCP server URL, which is localhost port 8001/MCP, which is MCP endpoint for our MCP server, as a URL. And finally, we define our agent. So we use agent object to define our root agent. The name is a root agent. This is necessary for ADK web to detect the agent correctly. Then we provide Gemini model name. The description is it is a tool agent, and instruction is you are a helpful assistant that can use various tools. So finally we define tools as agent MCP toolset. So this is exactly the object which is now considered as a tool for the agent. And this is pretty much the whole code. We are not doing here the extended version of the standalone agent because I'm going to run this agent using ADK web application. So let me clear the terminal. And I'm going to run ADK web, and let me provide port 8005. So our agent will run on this port. Alright, so our agent is deployed successfully. Let me show you the agent. Alright, so this is our agent. As I mentioned, this is a root agent. This has been automatically detected by the ADK application. So now we have a full-scale UI to use ADK agents. Okay, let me now ask the agent to write haiku about semantic kernel. And you can see that agent decides to invoke Azure Poetry Agent tool. Now it's actually invoking the tool and running it, and here's the result. Semantic kernel with prompts, tools, and memory, code briefs, and kernel. So the ADK agent was able to successfully select the proper MCP server tool to invoke the corresponding agent. Now let us repeat this exercise using the prompt for the reg agent. Okay, which hotels are available with full-size kitchens in Nashville, Tennessee? This is our standard prompt. We can see that the agent decided to invoke Azure Reg Agent tool from the MCP server. So now it's running, and here is response, and this is the same response which we have seen before. So to run a simple test, let me ask one more thing. This will be the general knowledge. So what is the capital of the United States of America? So this is a general knowledge question. And I'm expecting the agent to answer it using the Gemini model, not invoking any tool. Yes, and in this case, no tool is needed. The agent was able to leverage their knowledge of the Gemini 2.5 Flash model, and no tool was invoked. Alright, so let me recap what we were able to do in this video. So first of all, we have created two agents using semantic kernel SDK, the Poetry agent and Azure AI Search agent or Reg agent. Then we have deployed the API using fastAPI application, and we created two endpoints for Poetry agent and for Reg agent respectively. Then we have created multi-agent MCP server with two tools. So the tool 1 is calling Poetry agent and tool 2 is calling Reg agent. And also I have shown how to create MCP client and AWS Trends agent and ADK agent, which are able to talk to the MCP server. Let me show the structure of the code. So AWS root agent.py, this is basically Trends agent with the Bedrock model. The root underscore agent, this is a directory for the ADK agent. Agent.py is a definition of the Google ADK agent with Gemini model. And then finally, MCP client to call agent tool is a direct MCP test client. So these three hosts are connecting to the MCP layer, which is MCP server deployed at port 8001, and the MCP server is defined in file MCP multi-agent server. So this MCP server contains two tools, and the tools are talking to the endpoints, which are deployed using the fastAPI, and HTTP server with the APIs is deployed at port 8000, and the file is SK Azure Agents API. So we have two agents, SK Azure Poetry Agent, which is using chat completion, and SK Azure AI Search Agent, which is basically using Azure AI Agent and AI Search Service. So chat completion agent is connected directly to Azure OpenAI model, basically OpenAI GPT model deployed in Azure AI Foundry, and Azure AI Agent enabled with AI Search is using two services. So it's using Azure AI Foundry and Azure AI Search. So this is the overall architecture of what we have done. So let me conclude this video. We have completed very interesting architecture. And the reason for this architecture to appear is a comparison between agent-to-agent protocol and the MCP protocol. So I have shown that MCP server tool definition can be used similarly to the agent card descriptions, which allows dynamic selection of the agent. And this is the main idea behind building application and showing how we can do the multi-agent orchestration using the MCP server. To conclude, I would like to mention that I have a lot of videos about basic AI and ML applications, the agents and MCP. Finally, all the code is available here in my GitHub, so feel free to have a look and download this code. If you have any comments or questions to this video, please provide them below the description. And I'm looking forward to seeing you in the next video. Also, if you like this video, please click a thumb icon and subscribe to my channel. Thank you very much, and I see you soon